Welcome to today's webinar, Automating Management of Amazon EC2 Instances with Autoscaling. Our presenter today is Michael Honish. As a solutions architect, Michael accompanies lots of different companies of all sizes on their journey to the cloud. He enjoys making customers' lives easier by making sure they get the most out of their broad portfolio of services that the AWS provides. Michael's main interest is in building big data solutions and scalable web apps. Today we also have Marcel Guzman, Calvin Tang, and Chris Lewis, who will be our webinar moderators today, answering your questions throughout the presentation. Michael, welcome. The floor is now yours.
All right, thank you, Jerry. So yeah, welcome everybody to today's webinar. So thanks for joining us today. For the next, let's say, 45 minutes, I'm going to walk you through fleet management, as we call it, of EC2 instances using autoscaling. We'll do a presentation, a brief demo, and then open the floor for questions, which me and the moderators will be happy to answer. So, welcome from my side. Let's now kick it off. So when people think about autoscaling, they typically think about two things, right? They think about dynamic scaling, about like elasticity and creating instances on the fly. But a lot of people don't realize that the most common use case for autoscaling is actually fleet management. And what I mean by fleet management is that basically making sure that you have like a fleet or a group of EC2 instances, a fleet of servers under its control, and making sure that those servers are happily doing their job, right, and taking good care of them. Because as you run applications under like autoscaling setup, what autoscaling does is it checks the health of those instances and replaces them if need be. So if there's any kind of failure, if an instance dies, or if the application on the instance has some sort of malfunction, autoscaling would then move in and replace the instance and make sure that your fleet is restored to full capacity. And that in itself is a very cool use case and a very good thing to have for all kinds of applications. Throughout the presentation, you'll often see like an architecture diagram like this one that shows autoscaling being used with an elastic load balancer. And that's a very common setup, but that's not the only setup that you can use autoscaling for. I'll talk a bit about that later, but don't think about this as being just for web applications, etc. Right? You can also use autoscaling groups for batch jobs, etc. All right. Yeah, fleet management is what we'll cover today. The dynamic scaling part is related because it builds on that and maintains, let's say, a group of instances, fleet of instances of variable size. And then you can define metrics and alarms based on typically CloudWatch metrics that tell autoscaling when you will need more capacity, when your application is running short for one way or the other, typically based on CPU utilization. So it monitors that across the group, and if it sees like the CPU utilization rise above a certain threshold, then autoscaling will dynamically configure additional instances, so increase the capacity available for your application, register them with an elastic load balancer, for instance, if you need one, and just keep running your fleet. At this point, the fleet management kicks in. And of course, if CPU utilization goes down again, autoscaling will also terminate the instances if needed, which helps you improve costs and utilization of the instances that run your application. A lot of people, as I said, think of autoscaling as something that you can only use when you have like dynamic scaling needs, when you have like a very dynamic environment with like peak requests coming in at some point and like very low traffic at the other point, the typical web applications. But that's really not the case. And today we're going to explore mostly the other use cases for which just the fleet management portion of autoscaling is tremendously useful. And a lot of people actually are not aware that they can just ignore the dynamic scaling part if they don't want it or need it. And there's a couple of myths that basically circulate about autoscaling, which I'd like to clear up over the course of today's presentation. I mean, one is, right, as I said, my application doesn't really need scaling. I don't really have like those varying loads on the application. So I don't benefit from auto-scaling, so why should I use it? And as you've just seen, right, dynamic scaling is just one piece of it, which you don't have to use if you don't want to. Just the fact in itself that auto-scaling monitors your instances, tracks the metrics, and can heal them, meaning replace them if they experience problems, that in itself is already tremendously useful. So unless you enjoy like carrying pagers around, just this level of automation makes your life so much easier. Another myth we often hear is like that it's hard to use, right? And then briefly in a few minutes going to show you that that's certainly not the case. You can really get started in minutes and have like an auto-scaling group set up that looks after your instances. And finally, right, a lot of customers tell us, okay, my instances are all unique. They're like these little precious little snowflakes, or we have like stateful applications, so I can't really use auto-scaling. And typically what they're concerned about is that whenever like something happens, like whenever they're provisioning a new server, they want to be able to influence that process manually or go after like a special process before like an instance, like a server can be decommissioned. And autoscaling actually allows you to do that as well, right? And today we're going to spend quite a bit of time to explain like how this works, when this is useful, and I'll walk you through a couple of common use cases and scenarios. All right, so I guess if you can answer like any of those questions with a yes, then fleet management really is for you, right? If you have like applications that serve like a business critical need, you really want to make sure that you have a solid fleet management solution in place that looks after your instances, replaces them if need be. And autoscaling actually helps you to distribute your instances across 2 or more availability zones. And that's one of the patterns that we see and that we publish, for example, as part of our well-architected framework. And it's like really a key concept to make use of in AWS in order to maximize resilience and make sure the application enjoys the highest level of uptime possible. Now, before we have a look at how this looks in practice, I'm going to walk you through a couple of the basic concepts regarding autoscaling. And once we're done, you'll see that it really isn't that complicated and it's like very quick to use. All right, so if you start with a fleet of servers, well, it's probably only one, so that might not be worth calling it a fleet, but it already is, right? Because it runs an application that you care about, so you actually want to have some sort of management. Okay, you read about the well-architected framework and how to increase reliability and availability. So you figure, okay, I'm going to duplicate and set up another instance, a clone basically of the first one in another availability zone. So I have spread the load across like 2 data centers with like different security and risk profiles. So it really helps us improve the uptime already, because now if one instance fails, it's very unlikely that the other fails as well, because they're now in separate availability zones, separate data centers. Now, once you have this set up in place, you can already basically ask autoscaling to help you take care of these instances, right? You can really put those 2 instances in an autoscaling group. All you need to tell it is basically how many instances you want as a minimum, right? As a minimum you want to have 2 because you want to have like reliability even if one of them fails. You can also give it the desired number of instances, also 2 in this case for the same reason. And we don't really care about dynamic scaling in our use case. So we say, okay, maximum should be 2 as well, right? I really just want 2 instances, period. No dynamic scaling, nothing. And at this point, once you add those instances to the autoscaling group and set it to like min and max 2 instances, that's pretty much it, right? Then autoscaling will basically do its job, look after those 2 instances, monitor their health, and replace them if necessary. And if you need like an elastic load balancer, that integrates very well with autoscaling, because autoscaling registers the instance as controls within an elastic load balancer or several if needed. And it also automatically deregisters them before decommissioning them, or registers a replacement instance if the previous instance failed. So that combination is something that's very frequently used and also very easy to use. So what an autoscaling group does is essentially, it's a group of EC2 instances, and you configure it to basically always keep a minimum number of instances running, right? So in this case 2, it could also be 1, right? And then you give it a desired capacity, and a maximum, which basically controls the upper limit of what you want to spend or what is necessary for this application. And you can tell it your desired capacity. And autoscaling would then terminate instances if they fail, or launch new ones if the size of the fleet falls below the desired capacity, and just keep that process going. It can also distribute your instances across 2 or more AZs, which again helps with reliability. And I'll tell you a bit more about that in a moment. Now, since autoscaling needs to launch instances, for example, it needs to have some way to actually figure out what kind of instance it should launch, right? And so which size, which operating system, how did you actually install the application, things like that. And that is all controlled in another entity called the launch configuration, which basically just tells autoscaling, if you need to launch an instance, this is the configuration you should use. And that includes parameters that EC2 needs, like the instance type and size, the machine image you wanted to use, and all the settings that you would need to launch an EC2 instance on your own, like security groups, which SSH keys to use, and an instance profile, which provides temporary credentials for the instance to interact with other AWS services. You can also set the user data, and that is very useful in the context of autoscaling. Because, of course, the point of autoscaling, the point of like automated fleet management is that this launch configuration will just be launched automatically when needed without like requiring human interaction. Which also means that the installation and setup needs to be fully automated. That sounds like a lot of work, but you have to, especially if you use software that doesn't change as often. Just create like one, let's say, golden image, like an Amazon machine image with their operating system of choice, with their required management tools, configuration, and the application software. And then you simply add this AMI, Amazon machine image, to the launch configuration. And whenever autoscaling group needs to launch a new instance, it will just spin up a new instance of this image. If you have software that changes more often, or if you want to have like other processes controlling configuration and have a more complex configuration management system in place, you can also just use a base AMI, like a plain Amazon Linux AMI, for example, and then just install the code and configuration as needed. Again, fully automating it. The easiest way to do it is probably by just using the user data attribute. So that is an EC2 instance metadata attribute that is passed to EC2 whenever launching an instance. And this attribute can, for example, contain a shell script. It can contain information about packages to use, etc. And that's probably the easiest way to launch some kind of shell scripts, so bash scripts or PowerShell scripts in Windows, for example, as soon as a new instance spins up and allows you to configure it. You can, of course, also use deployment tools like Chef, Puppet, or Ansible, or pretty much any other tool you like, and just invoke them in your user data script, right? So spin up the base AMI in user data, call, let's say, install Chef agent, for example, pull in the recipes and execute them. AWS Code Deploy is a service which does exactly that. It deploys code, but it's very well integrated with autoscaling. So you can basically give it like an artifact, let's say a zip file, placed in S3, and various configuration of how it should roll out this code onto a fleet of autoscaled EC2 instances. And it allows you to do things like rolling updates, etc. So if you have like a lot of custom built applications that you run, that's certainly an option to look into. And finally, the Amazon EC2 Systems Manager, or SSM for short, would also allow you to run commands remotely and execute a lot of like configuration actions against Linux or Windows items. We'll have a look at some of those actions later on. I mentioned user data, and that's probably the most common one. And that's also one of the easiest ways to do it if you have simple needs. So this is one example for what user data would look like in my demo setup. That's basically just a bit of shell script that you pass onto the user data attribute upon launch and add it to the launch configuration. So all it does is it installs software updates based on Yum, so it's supposed to run in like an Amazon Linux instance, and then installs the EC2 Systems Manager agent, which then interacts with the SSM service to accept remote commands, create software inventories, patch software, etc. Right? You don't have to understand all of this or care about it all. It's just one example of how easy it is to run a couple of commands. And adding this snippet to the user data field in your launch configuration just means that all of the instances in your autoscaling group come already installed with the agent and with the latest updates installed. So they're ready to go. Another benefit of using autoscaling for fleet management is that it adds a couple of additional metrics and also dimensions to CloudWatch. So first of all, you can get group level metrics. So for example, each autoscaling group can be configured to report metrics like the number of running instances, the number of failing instances, how many have been terminated recently, how many are still pending for launch. Looking at typical EC2 instance metrics like CPU utilization, network traffic, network out, for example, and all that. For those metrics, using an autoscaling group adds an additional dimension, which allows you, for example, to aggregate the metrics and then get like the average CPU utilization for all the instances inside your autoscaling group. So instead of like having a bunch of widgets on your dashboard showing the autoscaling group instances and all of their CPU utilization, you can just have one metric which tracks the average and which helps you create alarms on that or create alarms on the outliers like maximum or minimum utilization to see if like one of the instances isn't properly utilized. And this allows you to easily set up widgets like this, right? So first, or example near the top of the screen, that shows you like how many instances are in service and like the CPU utilization across the fleet. And the other one basically is another view of those metrics. And using CloudWatch allows you to build custom dashboards and custom graphs with those dashboards, and also define alarms on all of those metrics, including the ones that refer to the group as a whole. All right, I said it's very easy to use, as you can just create an auto-scaling setup and an auto-scaling fleet for your application in a few minutes. And so let's quickly show you how that is done, right? So you should see the EC2 management console. And what we're seeing here is that I have a couple of instances running. And what I have here, for example, I have a couple of ones already running in an autoscaling group, but let's ignore those for now. Let's look at this one here, right? Which is, let's say, a simple web server, as the name suggests. That's just an instance with a security group that has like port 80 and 443 open. Really nothing special. It has an SSM role, so you can interact with the EC2 systems manager. And that's pretty much it, right? So it has like an application. I can quickly see if that web server is actually running. Yeah, you can see the test page coming from our URL. So Apache is up and running. Okay, so I can access that instance. Now, let's say I want to make this little web server more reliable. So I want to create another one of these instances, load balance it, and put it under autoscaling's control. So what I can do is I can easily, give me a second, I can easily just take this one instance and attach it to an autoscaling. Right? And basically say, I want to have a new autoscaling group, which I will call autoscaling demo, and add this one instance with this ID to the group. Now I can move over to the console showing the autoscaling groups that I have. See, I have another one for the demo, and this is the one that we just created. And that's it. Right? You now have an autoscaling group with size 1, so one instance maximum, minimum of 0, and a desired size of 1. So whenever this one instance dies, it will replace it. Now I said, okay, I want to have actually 2 of those and place them in different availability zones. So one thing I can do is basically configure this autoscaling group, which right now runs all its instances in availability zone US East 1B. So I'm just going to add another one, let's say US East 1A. And add like a load balancer so that all the new instances are added to the load balancer automatically. And now, let's say I want to have a desired size of 2 so that my load is spread evenly across both availability zones. And I want to have a minimum size of 1, and of course a maximum size of 2 so I can meet my desired size. All right. If I want to not use dynamic scaling, for example, I don't have to. I can even go a step further and say I want to protect these instances from scaling in. So that applies to all of the instances created by this autoscaling group by default, which means that if for some reason I misconfigure the group and drop my desired size to 1 or 0, it will actually not terminate those instances. So they don't disappear easily if I miss up my configuration. All right, so now I've saved it. You can now see that my desired size has changed to 2. You get a little eye here saying, okay, we probably need to launch a couple other instances. You can see the activity history, so attaching an existing instance. And looking at the group of instances, you see it still has 1 instance in service, but it will soon spin up a second one. And once that instance spins up, it will add it to the elastic load balancer that we've configured. Now that that's the case, you can see the second instance is pending. It now has a launch configuration name. And this launch configuration just got automatically created from the configuration that my existing instance had before I added it to the autoscaling group. So basically autoscaling just took whatever it knew about the configuration of that instance and turned it into a proper launch configuration. So now suddenly I have like 2 instances in service. And now they're being added to the elastic load balancer, and I have a fully redundant setup of like 2 web servers spread across 2 availabilities of load balance. And that's all the steps you need to make to actually go from one little instance to like a fleet, a managed fleet of 2 instances spread across multiple data centers. All right, I guess that showed you just how easy it is to use. Now, of course, let's have a look at what will happen next, right? I mean, ideally, in an ideal world, I now have 2 instances, load balanced, nothing would happen to them. They'll live happily ever after and serve requests and run the application. But what if something happened? What if, for example, one of the web server processes goes rogue and uses up all the memory, or if, let's say, just the hardware failure for one of the instances. In this case, that's exactly what fleet management and autoscaling have been built for, and will take care of those instances, and thus improve the reliability and availability of your application. Now, how does this look like in practice, right? As we said before, autoscaling keeps track of minimum, maximum, and desired capacity, but also keeps that capacity balanced across the AZs it has been configured for. So in my case, I configured it to use 2 autoscaling, 2 availability zones. So it will try to balance the capacity, so the number of instances in the fleet, evenly across both AZs. It also replaces unhealthy instances, right? And that's the part where it saves you from a lot of pain of being paged and having to rush in and look after instances that are misbehaving, because autoscaling will just spot like instances that are not behaving as expected, move in, terminate them, and replace them with a better one. This relies on health checks. Those health checks are performed periodically by the autoscaling group. By default, all of the instances are perceived healthy, but when one of the checks fails, the instances are marked as unhealthy and basically placed in a queue for termination. And all of the unhealthy instances are now terminated and then replaced, so you'll see another pending instance coming up. There are different kinds of health checks. So the default one, which I'm using right now, is the EC2 instance status. So EC2 runs a couple of checks for every virtual machine running in the service. So if like the instance state is not running, so for example, someone manually is stopping the instance, or if the system health check shows a sign of impaired, which could be a sign of a hardware failure, for example, then autoscaling will terminate the instance as it perceives unhealthy. If I'm using an elastic load balancer, I can also make use of the ELB's health checks. So the elastic load balancer also can perform health checks, for example, running HTTP requests against a certain URL, like let's say a ping page or just the index page to see if that returns, if it gets a HTTP status code 200 back. And if it does, then everything is fine. But if it doesn't, like if it suddenly gets a 503, meaning the web server has some kind of failure, or if it cannot connect the instance at all, then ELB will actually mark the instance as unhealthy in its own book, so to speak. But if you configure the autoscaling group to actually use those ELB health checks as well, it will get a queue, it will get a message from the Elastic Load Balancer and saying, hey, this health check really failed for this particular instance. It's now out of service. And then the autoscaling group will say, okay, out of service means something is wrong with the instance. It will just terminate it, replace it with a new one. And once that has spun up, it will add it to the auto scaled load balancer and make sure that can process requests. There's also a way you can mark individual instances as unhealthy. That is obviously useful for testing, to seeing like, does the autoscaling group actually behave as expected? It can also help if you want to integrate it with some kind of other systems, like if you have some other kind of monitoring system which maintains a view of your application health. You can use this system, basically reach out to the autoscaling API and change the health check result for an instance directly and mark that as unhealthy, which basically means making sure that it gets terminated. Now, let's have a look at this example. I have a few more instances here. I have an autoscaling group of like 6 instances placed across 2 availability zones, A and B. So now let's have a look at what happens here, right? All instances are healthy, everything's fine, but now suddenly one of them is broken. There's like a hardware failure in the instance here on the left. And as you can see, autoscaling noticed that, Elastic Load Balancer noticed that, took the instance out of service and marked it as unhealthy. So now autoscaling knows, okay, I need to get rid of this one. So just terminate the instance and replace it with a new one. And once that is done, add it to the ELB's configuration. Now, same state as before, I have 6 instances, everybody's happy. This actually works just as well if, for example, an entire AZ is like isolated from the network. Right? In this case, all 3 of those instances in AZ-A would just be marked as unhealthy. And autoscaling would remove those, and actually replace them with AZs in the secondary AZ just as well, right? That's one of the reasons why you want to configure your autoscaling groups to cover multiple AZs, so that this kind of behavior can take place. And you can quickly shift capacity from one data center into the next, for example. Right? I also said that autoscaling balances instances. What this means is that as soon as AZ-A goes back into service, autoscaling periodically checks that, and then starts rebalancing the capacity, meaning moving individual instances into the availability zone A. So this is an interesting case because, of course, autoscaling doesn't just want to shut down healthy running instances. What it does is it first creates a new instance in AZ-A, right? It doesn't want to reduce your capacity because you might need it. Then once that is set up, register it with the load balancer, deregister the now superfluous instance in AZ-B, and terminate that, right? So now you have part of your capacity in AZ-A again. And we'll do the same with the second one, register it, deregister and terminate the one instance in AZ-B, and the third time, and now your capacity is fully balanced again, like it should be, right? So if either AZ is isolated, you still have like 50% of your capacity and you're good to go. Now, what happens when an instance actually is terminated? That is explained by the autoscaling instance lifecycle. So as autoscaling creates instances, or if you add instances to an autoscaling group, until they are terminated, the instances follow a certain life cycle. So if you add an instance, that tells autoscaling to launch a new instance. and then it's held in a pending state. We briefly saw that on the console before. The instance is pending until it has fully launched, until EC2 has done its job. And then, once it's done, the instance is in service, meaning it's healthy, it can accept requests, it can perform whatever load it's supposed to do. Now, in case you either have a failed health check, so something is broken, or if you remove the instance manually, for example, by decreasing it, increasing the size of the fleet, the instance will now be moved into a terminating state, right? So, which means the instance is still running through the EC2, but it's no longer in service. So it's, for example, deregistered from the ELB, etc. And at some point, the instance is fully terminated, and that's it. If your autoscaling group now drops below the desired capacity, it will quickly reprovision a new one. There's another instance. In some cases, instance launches might fail, right, for whatever reason. And in this case, the instance goes straight from pending to terminating state and is quickly removed again. The state transitions we've seen, or we see here, happen fully automatically. So you don't have to do anything in this case. But there is one particular lifecycle stage that you can only invoke manually or by the API, and that is the standby state. Right? You can just take one instance, say, okay, put this one in standby. It will remain in standby mode, basically until you give it back to the fleet. During this time, it's seen as like healthy, so it's not being replaced. It's like in a special kind of state where it doesn't serve requests, but it's still there. And a standby state can be useful if, for example, you experience some kind of problems in a production application and you quickly want to take this instance out of service. So you can log in and have a look at what's going on, maybe reconfigure, look at the log files, etc. And if everything turns out okay, you can put it back into the in-service state. Now, this instance lifecycle is really useful, but ideally we want to have like some control over what's happening in the different stages. And there are two ways to do it, right? I mean, well, that's actually a good question. Why would we want to have more control, right? I mean, couple things. Typical use cases we hear about from customers is they want to attach some kind of resource, typically like an elastic IP address because they're not using an elastic load balancer. Or they have some kind of like registry they want to use where like all new servers, like replacement instances, need to be registered. Could be DNS, could be external monitoring systems, their on-premises firewall, which needs to be updated with some information, or their other load balancer which they run. It can also help like recover existing state from another system so that the instance doesn't start with a blank slate, but can really pick up the state of where the previous instance left off. A very common use case is that you want to keep the log files of the terminated instances. And if you're not using like a distributed logging system like CloudWatch Log, for example, you can influence the lifecycle and pull down log files before the instance is terminated. And I'll quickly show you how that is done. And to address those use cases, autoscaling provides two different kinds of mechanisms. So one is lifecycle hooks and the other is notifications. Notifications are just what it says on the sign, right? As an instance goes from stage to stage, the autoscaling group, the autoscaling service, sends notifications about what has happened. For example, once the instance is in service, it will tell you, hey, an EC2 instance launch has been successful, right? So that's good to know. Now you can add it to your monitoring system and things like that, or just happily see that the launch went well. If an instance launch was unsuccessful, that's also important to know. You might want to create an alarm and page your administrators because that might be a sign for like a deeper problem, for example. And of course, you also want to be notified if an instance terminated successfully. So it means it's gone. That's another kind of notification that is sent. Now, the notifications actually get sent after a state transition. So they don't allow you to control what is happening, but they keep you informed about what has happened. And this allows you to react to any kind of changes in the group. So instances being added or replaced. There are two delivery mechanisms. Well, actually 3 delivery mechanisms for lifecycle notifications. There's a simple notification service, which is an easy way to set up, for example, a text message or an email being sent to like a pager address. And you can also use Amazon CloudWatch events. That's actually the solution that I would prefer and that I would recommend. Because and how they are routed. This is what a sample notification looks like. As you can see, it has a bunch of information that can be useful when processing such a notification. It tells you which application, which autoscaling group triggered the notification. It can give you the instance ID, and it tells you what has happened. So in this case, it tells us EC2 instance launching, right? Yeah, and that's it. So this is things you can react to. Now, if you want to have more control, if you just don't want to react, but you actually want to be part of the action, so to speak, there's lifecycle hooks that allow you to really hook into the state transitions of the instance lifecycle. The lifecycles, when they are defined, when they are activated for an autoscaling group, the instances enter special wait states during the state transitions, like from pending to in service and from terminating to terminated. There's a special wait state added. And during this, while the instance is in the state, you can actually react to lifecycle events and impact the state, right? And of course, it creates another set of notifications which you can react to. So how does this look like? If the instance launch is pending, if there's like an autoscaling hook defined to fire on instance launches, the autoscaling group will put the instance in a pending wait state and invoke the hook. Right, meaning it will send a notification that this hook is now being invoked. And you can now, for example, run a script that processes or that runs on the instance or outside of it and does something that is important for the state. Like, for example, adding an elastic network interface, an elastic IP address, or installing software so that you can be sure that the software is there before the instance is taken in service. And maybe you want to decide, like, if you really want to take this instance into service, right? In this case, you just return a continue result. The instance will be taken in service. You can also abandon the launch process out of the wait state. If, for example, you run into problems or you suddenly realize that you actually don't need another instance because the load on your queue has just dropped, etc. In this case, you can just terminate it straight away. Similar mechanism for terminating wait states. If an instance is terminating and there's a hook that looks that allows you to hook into terminations, the instance will be put in a wait state, and then you have up to an hour to actually run tasks on the instance, clean up log files, save them somewhere else, things like that. And then once that is done, you can finish the hook with like continue or abandon. If you say continue, other termination hooks might run. If you say abandon, it's just terminated straight away. So two different things, right? The lifecycle hooks are executed before a new instance is taken into service or before it is being terminated. And the wait state is actually a state that is created so you can actually run work on those pending or terminating instances. On the other hand, the autoscaling notifications really get sent after an instance has entered the in-service state or if it has entered the terminated state. Right? So you can only react, you can no longer influence or stop the transition. Now let's see what this looks like in action. Right? And this is one example that shows you how much control you can actually have over the instances and how they're being provisioned. But this is just one sample architecture. I'm quickly going to walk you through how this looks like in practice. So let's say we have an autoscaling group of 2 instances, and what we want to do, we want to make sure that before an instance terminates, we want to, let's say, zip up and save all the log files on this particular instance so that we can have a look at them later. Maybe we need them for compliance reasons, auditing reasons, etc. So what we can do is we can configure a lifecycle hook on the autoscaling group. Now the lifecycle hook also fires CloudWatch events, which means you can define a rule in the CloudWatch event service that will trigger once the hook is involved, so once there is some kind of state transition. And then in autoscaling event rules, you can extract some of the data from the event, like the instance ID, etc., and invoke other targets. So one target could be just send a notification, like a text message to an SNS topic, but you can also invoke a Lambda function. Right? And this is where things get interesting, because you can run a Lambda function, which means you can have a piece of code that just gets executed whenever like one of your instances from the autoscaling fleet is about to be decommissioned. And of course, in Lambda you can do all sorts of things. You can modify the state of the instance. You can modify other AWS services that might be related to your application. But let's say you want to just really log on to that machine and execute a command. You just want to log on and say, okay, zip up everything in /var/log, create a zip file, upload that to S3, and then once you're done, yeah, you're done. And then I'm good terminating the instance. And to save you the pain of like managing credentials and what kind of commands to run, etc., you can use EC2 Systems Manager, right? So EC2 Systems Manager has one component that is called run command, which actually just does that. It allows you to run a number of user-defined commands, which you define as part of the service, which means it is being versioned, it's being audited, you can restrict access rights, etc. on the command and track like who is running that command against which instances. And then the command actually is sent to system component, the SSM agent, which is running on the machine itself. So the SSM invokes run command on the terminating instance, tells it which commands it should execute. In our case, it just says, okay, cd/var/log, so move into the log directory, zip everything up, upload the zip file to S3, right? And once that is done, let us know, right? So the Lambda function is actually observing the result of that run command. And if it's happy with the result, it will just complete the hook. So it will talk back to the autoscaling service and say, okay, I'm done. You can now leave the terminating wait state and say, yeah, now the instance is safe to terminate because I've captured all the state information that I want to take. This is all fairly easy to do. If you want to write a lifecycle hook, you just basically write a piece of code that you want to have. I can maybe show you one example. Create a rule in CloudWatch events, which connects this rule to the events issued by the lifecycle hook, and then associate the lifecycle hook with the autoscaling group so that it actually starts sending events. And in the lifecycle hook itself, you extract like the metadata you need. So you typically need the name of the autoscaling group, the instance ID, so that you know which instance you want to run commands on, and maybe other kind of configuration parameters. Then you can just do arbitrary things. Just need to be aware of timeouts. So there's like a 1 hour timeout. If your hook doesn't complete within that time, you need to send like a heartbeat, which will give you more time to complete what you're doing. And once you're done, you just call complete lifecycle action to signal that you're done and that autoscaling is safe to proceed. And the code can actually be many things. It can be a Lambda function, it can be a run command, it can be any kind of code that consumes streams, SQS, SNS, for example, right? So there's various ways to hook this together. Very recently, we actually launched an addition that allows you to trigger run command just directly from CloudWatch events. So you can actually save the Lambda function and save a bit of configuration effort. This is actually what my run command looks like. It's basically a shell script wrapped in JSON. You can see that it looks at that it retrieves the instance ID, retrieves the region from the EC2 metadata service, and then all it does really is it does S3 copy, it takes a tar file which I've created like in a piece of the omitted code, uploads that to an S3 bucket and a prefix named after the instance ID. And then once it's done, it just uses the AWS CLI to complete the lifecycle action. At this point, you're good to go. Right? This is, once you have the code, you basically turn it into a Lambda function or turn it into a run command. Then you create a new rule in CloudWatch events. So this is what it looks like. It just says, use service name autoscaling and event times like instance launches and terminations. Then you can say, okay, I'm only interested really in like instance terminate lifecycle actions. And maybe I'm only interested in like one particular group. I don't care about the rest of the group. This is what I like about CloudWatch events and why I'd recommend this approach over just using SNS for notifications, for example, is that it allows you to have like fine-grained control. You can have groups that trigger on anything that happens in any autoscaling group. On the other hand, you can have rules that trigger only like on a very, very specific event in one particular group. And you can route those events to different targets. For example, in this case, our demo backup function, which in the end, it just reaches out to SSM and executes that piece of code. Then use the command line to just add the hook, a termination hook, so a hook that fires whenever an EC2 instance is entering the terminating state, which is then referenced in the CloudWatch events lifecycle. And techniques like these really allow you to deal with stateful applications in autoscaling. So basically have your cake and eat it, have stateful applications, but also automatic fleet management. And this is one approach how you could use the same mechanism, the same architecture which I just showed you, to deal with stateful applications. And just to give you a rough idea, like while the application is in service, while the instance is in service, the application could just persist state between AWS volume on a regular basis, right? It can tag the volume with the application name and the instance ID that you know which volume it belongs to. And if autoscaling notices that the instance is broken, it's unhealthy and needs to be replaced, you can add a hook to the autoscaling group, trigger the instance terminating lifecycle action, which does that have like an application name tagged on them, but don't have an instance ID. In this case, you can just find those using the EBS API, attach them to the new instance that you spun up, tag it with the instance ID, and just resume the application. It will pick up where the previous run of the installation on the now replaced instance left off. So I hope you agree with me that autoscaling really is easy to use, right? And it really helps you make your life easier because it monitors and heals instances. It integrates with CloudWatch for monitoring. It replaces instances automatically, but it also takes care of AZ rebalancing, which is a tremendously useful feature to have because it really improves the availability of your system drastically. You've seen how you can get started in minutes, right? I mean, you don't even have to start with like autoscaling configuration. You could just take an existing instance and start off with that and just make your system more resilient by adding a couple of configuration options. And bootstrapping, so automating the instance creation process, is also very easy. As you've seen, it can be done with a couple of shell scripts, but it can also be part of like a more complex system as you've seen in the later part of the presentation. And it works really well with stateful instances, because you can keep track with notifications about what is going on, so you can react to state changes that might be impacting your application state. And it provides a lot of control by lifecycle hooks. And CloudWatch events makes that very easy to use and very powerful. Okay, with that, let's conclude the presentation and make time for questions and answers.
Well, thank you, Michael, and thanks for the great presentation and engaging with our audience today. On your screen, you'll see live poll questions, 3 at the bottom and 1 at the top. Please feel free to complete those. Your feedback is very important to us. Looks like we have just about 8 minutes or so left in our Q&A session, so please feel free to continue submitting questions in the upper left corner in our Q&A panel. We'll start addressing some of those that have been submitted, but we do apologize if we may not get to all of them in advance today. So again, let's go ahead and start our Q&A session.
All right. So one question is, can you show policies attached to the SSM IAM role? Yes, I can. So for the rest of the audience, if you want to use IAM, you need to start the instances with a specific EC2 instance role that allows the instance to talk to the excuse me, to talk to the SSM service. And if we have a quick look at that, let's see if I have my IAM console open.
Michael, did you want to share your screen?
Yep. Can you quickly share?
Okay, let's go ahead and you can start sharing the screen there. We do have a smaller view in this layout, though. So we'll look and see how it shows.
Okay, can you see my screen right now?
We can't yet. We'll have to have you share your screen from the Adobe. And let's just make sure that this is going to...
I'll zoom in. So if you look at the instances that we had running before, my simple web server instance actually uses the same policy. So this is the IAM role it uses, called SSM Managed Instance. And all this group does is two things. It has like the manage policy for SSM, which basically gives the instance permission to everything that SSM needs to do. Right? So there's like an Amazon managed policy which you can just attach. And a custom policy, which I'm using, which just allows the instance to complete lifecycle action, so make that API call from the instance itself and publish to SNS. So send a notification once you're done. Okay, back to the other questions, I guess.
At this time, I'd like to extend a special thank you to our presenter, Michael, for his time and a great presentation today, as well as to Marcel, Calvin, and Chris for the moderating today of all our great questions that came in through our audience today. If you have any comments on our previous or upcoming webinars, or suggestions on topics that you wish AWS to cover in future webinars, please feel free to email us at aws-webcast@amazon.com. Your feedback will help us improve our webinar programming. Thank you to our audience today for taking time to join us today. Enjoy the rest of your day, and at this time you can disconnect.